Okay, so I'm trying to get into the habit of answering more of these questions with a video, so that's what we're doing. So today's question is about the interface segregation principle. And we're going to take a step through about why it's probably not what you think it is. All right, here we go. We have a brand new empty writer project. Now, this is just plain C#. Nothing about this has anything to do with Unity, so we're going to keep things nice and simple. So, step one, let's start with the particularly odd example that was chosen. So we have our gorilla class, and a gorilla is a thing. And you know what? We'll hide all of that for now. We have a gorilla. Now, the idea was, what if you had a interface of arms, and then an interface of legs, and hypothetically we have our gorilla here, which has arms and legs. Now, the example was, what if, I'll just move these out to their own classes so you don't have to think about them. And there we go. So now, we have a gorilla, it has arms and legs. Now, let's take a scenario. Like we have some kind of damage that could help if I could spell. Calculator. Now, damage calculator is going to have something that says calculate limb damage. Now, the hypothetical scenario we talked about is, well, what if I don't want to enforce a dependency on gorilla here? Which makes perfect sense. We shouldn't only be able to calculate gorilla damage. What if we had a, I don't know, let's go with sentient teddy bear. Our teddy bear also has arms and legs. They may be stuffed, but they are still fundamentally arms and legs. And what's wrong with you, other than my... Oh, class, of course. It should be a class. Anyway, so we have our different things, and we're dealing with our damage calculator. So we don't want to hard code this, otherwise we won't be able to use our teddy bear inside this damage calculator. The theory is that, well, okay, we don't need this, but we want to, based on an interface segregation concept, only really put in the things we care about. So we care about arms, and we care about legs. Now the question becomes, is this starting to repeat ourselves? We don't really need multiple things. What if we add, you know, some other kinds of limbs like eye stalks or something which technically counts for whatever, or tails or whatever? Do we really want to go down this road and have infinite problems? Because that doesn't really solve our original premise. Now, let me first start with saying that this as a concept is generally something called downcasting. So what we're doing is we are taking a complicated thing and we are casting it down to something smaller. This can make sense depending on what you're doing. And what sometimes people do is they'll pass in one type of thing and then they'll type check it against others. So if arms is legs, and that lets you check for other types on the same object. This is horrible. Don't do that. But we are right in feeling that there's a bit of a code smell by having multiple things in here. So the first part is, why do we have these interfaces? Because the truth of the matter is, what we've got here is a need for limbs. And we are using this general concept of arms and legs to somehow handle that problem. Now, the kind of complicated code answer to this would be, what something is has absolutely no bearing on what something else needs. So, hypothetically speaking, this thing here actually needs limbs, and completely unrelated to everything else, you have this concept of an animal. And so you could have something like animal limbs, and that takes in some kind of animal, and or it could just take in the individual limb portions. We have our legs, arms. Well, I am just messing up my spelling today. And then it does various limb related things, and so, I don't know, something like that. And then we'll give these two properties, and so pretend that's why we need the concept here of our limbs. And so that is there. And then what we might do over here is we will, where's our refactoring? Refactor this, extract interface, general concept of limbs. All limbs has is our count. And at this stage, it doesn't need to be count limbs because we're in a limbs class, so it can just be count. So effectively, limbs have a count. Now, what we can do here is we've now got a concept of limbs. So our damage calculator requires limbs. Unrelated to that, our gorilla here has arms and legs, which now by proxy needs to provide a dedicated count for the limbs, which kind of defeats the need for it later, but that's beside the point. Either way, this thing here, animal limbs, is a composite that can be used in any scenario. Now, this is, I'm not going to lie, very confusing because it's a particularly sort of silly example. You wouldn't really use arms and legs in this scenario. So what we're going to do is we're going to throw all of this away and we're going to pick something a lot more sensible. But we're going to reason it through the same way. So we might have a shop. And a shop might want to have a sell function. And a cell might have a product ID and might have who you're selling it to. So we might start, so let's keep it simple and go through the steps. So you have a player, and player, and what you might do is you might end up having the player then internally have a wallet and all this kind of stuff. And so what you might do here is you'd have your wallet, and then a player has a wallet here. And so somewhere internally in this shop concept, you are dealing with the wallet and dealing with maybe an inventory as well. And here we go. And now you're kind of getting into the, okay, so in here, and we have maybe like real shop. Real shop has a shop reference. And inside of here, we're going to do something with player wallet and player inventory. And I didn't give a player inventory yet, did I? That's fine. We can just do that now. Inventory, create get only inventory of type inventory. There we go. Now we're not going to use them here, but you get the idea. Now, this is sort of very similarly the same problem, only now instead of our gorilla, it is a player. Now, here's the thing. We don't need a player for a shop. It may seem like it, but we don't really. What we actually need, to go back to this interface segregation concept, is to do a sell, we need a wallet that will perform the purchase, and then we need the inventory with which to store things. Or at least that's what it may seem like. And so now, we have to make that public, and we have to make that public. But now we're getting into the same problem. What if the items you sell might require specific class types? So are you the correct class to do this or whatever? So now we're back in the same problem, except rather than arms and legs and whatever, we're dealing with a problem that's more reasonable. So how do we solve this? How do we avoid now going, oh, actually, well, the shop now actually cares about your party because there's a concept of how many people's in your party, and you're going to combine you know, the different people's party properties, and then maybe there's the concept of a class or specification. And so now, in order to do a sell, you need to also know about a class, so you can check if they can equip it, and you need to know about the party to know if they have enough space. If you use that prefix there. Party. So now we're back to the messy, oh my god, I don't want to be doing this. So you're right, code smell, this doesn't feel right. But the question is, what is the real problem here? Is the real problem that we have too many interfaces? Is the real problem that our, you know, the objects don't make sense or the context makes sense? Well, no. The real problem is we misunderstood the relationship between the shop. See, what we've got here is the presumption that a shop needs a player. And we said, no, maybe it doesn't need a player, it needs parts. The parts of the concept of a player. And then we try to pass those in. But all we've done is we've unpacked the player and then still passed the player, effectively. Because we don't actually need all of this. What we're doing is, what does a shop need? Well, at a very, very basic level, a shop needs a buyer. That's all the shop needs. You want to sell a product to a buyer. Now we can get rid of all of this rubbish. Shop can have a buyer. And now we can get back to where we were. Now the question comes, yeah, but I need to know like information about the wallet. So it will do you. What if we said we have a product inventory, and then we have this concept of a product. Products have a price. Do that, and then we can say, let's just start with the very basics. Product, and we'll say get all. So our product inventory has a list of all the products, right? Now, here is our real shop. And let's actually separate this out too, just to be really, really clear. Real shop sells to a buyer. Now, our real shop is going to take in some kind of product inventory. So we'll say products. So we've got products here. And that, of course, needs to be public. So what do we actually need to do to deal with a buyer? Do we need a wallet and an inventory and all of this stuff? Well, no. What we need to do is we need to ask a couple of questions. So we need to get the product. And product equals products.getAll. Actually, you know what? I'm going to make a very specific with ID for this one. Product with ID. And it is going to pass in back a product. And that needs a class for that. And now we can head back over here. And oh yeah, our sentient teddy bear is no longer at play. So real shop, close others. Here we are. So we now have a product. And of course we can check if product is not null. Or actually we'll say if it is null, we will return. Now, how I'd actually write this is kind of irrelevant. We're not going to deal with that right now. What we will say is we now have a product from the inventory. Do we care what it is? Not really. This particular shop sells products. We got the product. Now, what do we need to do with the buyer for this context? Well, we might just need to ask if buyer can buy product. I said, yeah, but what does that mean? Well, the answer is it doesn't matter what it means. What it might mean is something to do with prices, something to do with inventory, something to do with party. So now what we can do is we could say maybe our player is a buyer. And so the player may still have all of that stuff. So maybe a player does have a wallet, and maybe a player does have a inventory. Only the question I actually care about is, can I buy the product? Well, does the wallet have enough money? Or actually, well, I'll make it simpler. We'll say has at least product.price. And then we're going to say and inventory that can fit our product.size. So let's just create those properties, and that should be an int. And can fit is just going to be a standard function here, which is going to return a boolean. And yeah, and then has at least, very similar. It's going to take in our price, or actually we'll say amount, because that's really, does the wallet have X amount? But whatever, we're not writing this perfectly. We are testing our theory. So all of that is to say, a player is a buyer checks if it can buy something, and then a wallet, whatever, inventory, all these different things. This is irrelevant though. So this gets back to our point. Does my real shop need a iWallet and an iInventory and an iStats? No, it needs a buyer. And a buyer is somebody who knows if they can buy a product. If they can, I can say maybe a shop also has a wallet. And then I can say something like wallet.put buyer. And buyer will take product dot price. And then we will say let's say buyer dot give product. There we go. And we'll just make those. I'm not going to bother plumbing these correctly. We'll just fill those in pretty roughly. And it's actually a product. Why not? Might as well be slightly accurate. And yeah, same there. And that should be sure, int amount. Actually, we need a void for that because we're just taking the amount from the wallet. And we will do that. Okay, I can't help it. I am slightly plumbing it for real. Amount. And there we go. Yeah, there we go. So put, I'll split this out too for simplicity. There we go. Take the price and then put into that wallet the product, that price, and then give the buyer a product. Oh, yeah, because he's null. Yeah, okay, let's just do hard code it for now because I don't care. Although we would probably pass. Actually, don't need to have an instance, do we? I don't care. This is kind of irrelevant. We're just going to set it to null. It'll still give us a warning, but at least we're being explicit about what we're doing. Actually, you know what? No, I'm gonna be one step further because I can't help it. Here we go. Wallet gets injected, signed to the variable. Not our problem anymore. Now it's possibly uninitialized, but it has been assigned. And you don't like it because it's before it's declared, but it shouldn't be because it's declared inside of the constructor. Oh, because he's the wrong wallet now. There we go, job done. And he, type of property price, int price, yes, he's there. Wallet.put should actually be an amount. Thank you. Okay, a bit messy, but we got there in the end. And also we can now invert that to be a bit cleaner. So all of that is to say, we want to sell in the shop a product. This product to this buyer. We get the product from our products. If we don't have it, we return it. If the buyer can't buy the product, we return. Otherwise, we take the price from the buyer. We put the amount in the wallet of the shop, and we give the product to the buyer and possibly remove from the inventory of the shop if it's a limited run product or whatever. Now, this should hopefully highlight that when I say buyer and I say wallet and I say inventory and I say all the other different parts, these are unrelated concepts. Arms and legs have nothing to do with limbs in that other metaphor. If a thing needs limbs, give it limbs. If a thing needs arms, give it an interface for arms. If arms can be a thing inside of limbs, you can do something else with it. And this comes back to this concept here. And right now, our concept of a buyer is a player. But here's the thing, I wouldn't actually do that because you don't want to make a player a buyer, because now for every single change, as I sort of cleared this out as an example, every change to buyer, we're like, oh God, now I have to add all this stuff to player. Well, is that really anything to do with the player? No, it isn't. That's because a player isn't a buyer, but a player can take part in the concept of buying. What do I mean by that? Well, we've established a buyer is a thing. So we have a buyer of type I buyer. And then what is a buyer? Well, what if a buyer is those other properties we talked about? So we need a wallet, we need an inventory, can buy, and we can take those two and put those here. And we will say give, we'll give to the inventory, give that product. Back out of that. Take is just going to be pretty straightforward, which will be wallet.take amount. And we don't really need to return anything for that. Although, To be precise, I would probably actually have some kind of validation check in case the wallet may not have enough money. But again, we're keeping this nice and simple. This most definitely isn't a gorilla class anymore, but that doesn't seem to matter. Don't worry. Once I've gone through a bit of simplicity and cleanup here, we will take stock of where we are. I know I'm throwing a lot of stuff at you, but we'll get there in the end. Okay, yeah. Buyer has these two. That's that. That's that. That's fine. There we go. And then this is going to be a wallet. And this is going to be an inventory. Now, what did all of that do for us? Well, let's make the concept of a game now. So let me just extract all of this mess out, and we will simplify this idea. Actually, player doesn't need any of this anymore. All the player actually needs is a player has a wallet, and a player has an inventory. It just might happen to have those things. Get rid of shop for now here. Move that. Move that. Move that. And that. Actually, yeah, there we go. Move from the inventory. And wallet. Okay, so we've got all our separate pieces, and this class should now actually be renamed to wallet. And last but not least, we will make something called a game, just so we have an entry point of our application. So here we go, game, and we'll close everything else. Now, let's see what we have and talk through it. So we have the concept of a inventory of products. So we will say, cool products, and this is going to be a, what did I call it? Inventory, product inventory? I can call it product inventory. Yeah, there we go, product inventory. This is a product inventory. We need two things to be a product inventory. I'm going to get nice and lazy, and I'm just going to say it's a list of products. And to return all, we'll just return this. And then to get one, we will return this dot first or default, where the ID, we don't have an ID, I'll give it an ID, is equal to product ID. Yeah, do that. And so we now have an implementation of cool products, whatever that means. Do that, and so let's start our game. So we have our game, let's have a constructor, and we will start by making products. We'll say products equals new cool products, and we will give ourselves some products. Now I don't have to write these out messily, so we're going to do it nice and quick. We're going to say add, give it a name. We'll have the IDs auto increment as a cheat. Don't actually do this, but again, this is a test class, so we'll cheat that one. And we'll say price. And then what this will do is it will be adding a new product with ID is equal to last ID. And the reason I'm inverting that, by the way, is I do want it to increment. I don't want to start with 0. I want to start with 1. So ++ on the left pre-increments. And then price equals price. Name over here, string name, all good. Now we can one-line this to be a little bit cleaner. And this, it's going to start with 0, but yeah, we'll leave it there. I think this wants me to underscore it to be consistent. Good. Okay, here we go. Start here. Close out the tabs. Products equals cool products. And let's add some. Let's add a apple. That'll cost 1. And we will add a sword. That'll cost 10. There we go. We have products. Now we need our shop. So shop equals new real shop. And real shop takes in what? Well, it takes in products. Now real shop is also going to need a wallet. So we'll say shop wallet equals new wallet. I don't think we have a wallet, so we'll just go leather wallet. Why not? A leather wallet doesn't exist, so we'll create type, and it's going to be a wallet. Wallet is going to be really simple. This is just going to be an amount. Return amount is greater than or equal to amount. Put is just going to take amount and add the amount. That's not take, that's actually amount. Yeah, and then take is just going to subtract. There we go. Again, not super exciting. We're not really building a system here. We are just plumbing pieces. So we have a leather wallet. Now, our shop has a leather wallet. Let's actually inline that because I'm lazy. There we go. So we have a shop. Products in our shop. Shop has those products and it has a leather wallet, and maybe we want to construct it with a set amount. Let's say they have 150 coins. And so what we'll have to do is add that, create the constructor, starting amount, and amount equals starting amount. There we go. So here we go. Shop starting amount 150, and let's just clean that a little bit because it's starting to get a little bit messy. So there's our shop. Now we talked about the concept of a player. We have a player. Player equals new player. Now a player should have a wallet and possibly an inventory. So let's say inventory equals small bag. So we have a small bag. It is going to be of type inventory, and we'll say it has a size of 30. And we'll say can fit is equal to in use. Obviously not a real wallet, so, or real bag, so just ignore the details for now. And we will say can fit is equal to return product size plus in use is less than size. So there we go, if it can fit. And then give, for now, will just be, we'll cheat, in use plus equals product dot size. Obviously you'd store it in some kind of list or whatever. Do I care that much? Maybe, you know what, I'm kind of doing everything else correctly. I might as well do this semi-correctly as well. So an inventory is actually going to be also a list of products, although it should be a list of items, but again, we're not going to quibble too much about details in our small little system. So what this will actually be is give will be, we'll add that product. Can fit is going to be, let's see, this dot sum all of the existing sizes, and is that plus product size less than size. So now, there we go, and we'll change that to max size. So, or actually, you know what, capacity. There we go. It's found. Oh yeah, because it's inheriting from the list. So we will say inventory capacity. You know what? I know I'm changing my mind a lot, but hey, that's, you're getting to see a look in how things really work. There we go. So underscore capacity, there we go. Can fit is equal to, is the sum of my existing products plus that equal to, there we go. So now this may be, when I say for real, it's not really how I would do it, because again, I'd be testing as I go, but this will give you an example of how I'm reasoning through it at least. So player is now going to need its inventory, and you know what, we're just going to say, I'm going to do the same thing inline. Say a small bag with 50 capacity, and then a player is also going to need a wallet, so we'll say a new leather wallet, and they have 40 coins. Let's clear that, and this is going to tell me that there isn't a constructor for that, which is fine, and so we're going to say capacity, we'll say start capacity, and then capacity equals start capacity, and then leather wallet is going to be the same. He doesn't have, oh, it does a starting amount. So now we need the two objects in the constructor, which will be a small bag, but that's not really a small bag. That should actually be our inventory. And that should be a wallet of type wallet. And then, as is probably no surprise, wallet equals wallet, and inventory equals inventory. I really wasn't planning on actually making this, but hey, we're we're pretty much down the rabbit hole at this stage. So we're just seeing the pieces come together. We now have a shop. We now have a player. Now, here's where we get to the important part. Shop dot sell. So what are we selling? Some product to some player. So now, if we do ID, we can just say sell product ID 1, which will be, in this case, our apple. Now, if we're going to sell our apple to the player, we can't just pass in player, right? And we talked about this. We could make player implement buyer, but then if we did that and we went to our iBuyer, we would have to put all of this rubbish onto a player. And this has nothing to do with a player. It has to do with a buyer. Is a player a type of buyer? Maybe, but it might not be. So what it actually is a combination of a place to put something and the resources to buy something. So a very simple buyer could just be player as buyer. And that's going to be a new buyer. And we're going to happen to use the player's wallet and the player's inventory. So now we can pass in the player as a buyer. So what this means is that as far as a shop is concerned, it is dealing with a buyer, which looks like this. It doesn't know anything about inventories or wallets or possibly other complicated portions of the process. It just cares about what it cares about. And likewise, a player knows nothing about buying or shops. It knows about wallets and it knows about its inventory. Why go through all of this hassle for a complicated nested set of stuff? Well, I talked before about how the point of software architecture is change. And so given this structure we have here, what can change and how easy would that be? Well, what if we had a infinite wallet or a magic spell that generated infinite money? And so what we might do is a infinite money spell. And currently it represents a wallet. But if we go in and we do this and we say has at least, infinite's going to be yes. It's always going to have at least because it's whatever. Put doesn't really matter. It's infinite. It's not going to do anything. Take doesn't really matter because it's infinite. It's not going to do anything. So our infinite money spell is doing its job. Now here's the thing. We call this wallet. Is this really a wallet anymore? Not really. It's actually a source of money. So I'll say a money source. And we are not going to change all of the other references. We're not going to change him either. And we will leave all of the others. You know what, don't rename any of them. So we have a money source. There are two types of money. A leather wallet, that's a source of money, and an infinite money spell is also a source of money. So this is just a different source of money. So now our buyer here actually takes in two things. A source of money and an inventory. So this source of money can be anything. And what I mean by that is this is a player as a buyer, but now what if the player wants to buy from the shop but not use their wallet, instead use a infinite source of money. So maybe we had some ismage and then maybe put in some flag here. Money source equals if ismage, we'll use the infinite money spell, otherwise we will use our wallet. There we go. And then maybe we have another class later, which is some kind of trader. Maybe you can play as a trader. And a trader might actually have a horse. So a horse, and a horse, I can't even spell horse. And a horse might have saddlebags. So the bags on the horse might be a storage medium. So we could call it an inventory. And we could basically say, can the horse fit whatever? And so what this will actually be is a horse has a leather wallet, but it's not really a leather wallet, it's a saddlebag. We'll keep it simple for now. And so, yeah, we'll just have one. We're not going to complicate matters too much. We'll just say internally it uses a new leather saddlebag with a capacity of 50. And that's just going to be whether the saddlebag can fit. So let's see. I said a leather wallet. No, this is not wallet. This is going to be an inventory, isn't it? Now I've confused myself. Where is the leather wallet? Where is my inventory? Do I not have different inventories? Let's have a look. Maybe have I not made these yet? 2 usages. Player and yeah, actually I haven't created inventories yet, so all I have is the one product inventory. I haven't done real inventories. So let's actually just take a quick pause here. So inventory, that's our money spell. Get rid of him. Inventory. Let's go with small bag. And that is going to be a type of inventory. And then we're also going to make a pocket dimension. And it's also an inventory. Now, for this to be these things, you need to place in the spells. So can fit will just be, again, infinitely true for our pocket dimension. And give will just be a, keep this one simple. It'll be a list of products, and we will just add that product whenever we add it. And we're going to have to instantiate our list. There we go. There we go, pocket dimension. So you have a pocket dimension. Also, that wants to be read-only. I can't help myself. So pocket dimension, and then we have our small bag, and our small bag inventory. Or it must have already made a small bag, did we? When did I do that? I did make a small bag already. Well, there you go. I didn't even notice. Well, hell, I was gonna get the 2 anyway. So a small bag is our saddle bag. There we go. Saddlebag dot can fit product, and then saddlebag, and then we will give that product. So all of this is to say, you can put stuff in a bag, you can put stuff in a pocket dimension, or you can give it to your horse. So inventory isn't even a good name anymore. This isn't actually inventory. This is a item container. And what we could say is arguably this is no longer a product. This is really an item. So let's just rename that for simplicity. So we now have items container. You can give it an item, or you can check if it can fit, and that's going to be size. Now we're back to this. Horse is an item container. A saddlebag is an item container, and it can receive items. Move that, and so we're going to keep these horrible flags that I wouldn't really do for now. So is a mage or is trader. So now we could say if you're a mage, you'd use the magic spell, and we could say destination is equal to, are you a trader? Well, you're going to pass into the horse. Otherwise, you are going to use the player's inventory. There we go. So, phew. What we've got now is we've got this concept of a shop that isn't changing. It is selling to a buyer. We have player as a buyer, which is the thing that can possibly do buying. Right now, it is using some money source and some destination. And because of the system we've built, we can create all kinds of buyers. We can have a buyer that buys using magic spells and saves to pocket dimension. We can have buyers that use their money, their wallet, and then store it on a horse. We could maybe create some kind of magical imp that goes to the shop for you as an NPC. We could have money sources that is actually, some kind of your own store where you can siphon money from a store that you're currently using, and that way it's part of a internal trading system. All of this doesn't impact this because a shop only cares about the concept of a buyer. It doesn't actually care about wallets and bags and horses and magic spells or whatever. So the complicated, long-winded answer to your question is, what do you do with the gorillas that have arms and legs? Well, you do nothing. If a gorilla needs arms and legs, you give a gorilla arms and legs. If you've got a script which might need arms and legs, does it really need arms and legs, or does it need limbs? If that's the case, give it a function called limbs, and it can use anything which has limbs. Those limbs might be arms, they might be legs, they might be something else. So the point is, you don't need to overthink it. It's not a whole series of complicated how low can you extract to. That's not the point of interface segregation. It is about use the level of complexity that something needs. Don't downcast where you arbitrarily take Gorilla and downcast it to 50 smaller interfaces, because if something needs 3 of those interfaces, should you really be splitting it down that far? Maybe what you've actually got is animal, and animals have arms and legs, or rather than arms and legs, maybe limbs. Maybe limbs is at the baseline. And so if you've got something later that needs to calculate damage to limbs, maybe you have 2 or 3 different parts of that system. So I guess what I mean by this is it's perfectly fine to have a some kind of system like that can take damage and that can be healed. So a player can take damage and can be healed. You might have crates which can be damaged but can't be healed. If you later on have some kind of a system where you need to deal with healing and restoring, don't pass it 2 different things, I am healable and I am damageable. If that concept is a compounded concept, then make something that can be both healed and damaged, called a restorable or a damageable, which damageable could be a compounding of I take damage and I heal or whatever, and then deal with that. And so if your existing things don't contort to that particular shape, then make something that does and pass in the parts that you need to pass in. So this may seem like a lot of individual pieces, but keep in mind, we just built a system here that deals with infinite amounts of inventories and money sources and shops of different kinds, which we didn't even cover. We have shops of different product inventories where the product inventories can come from different sources. We could have multiple shops using the same product inventory. So maybe there's like a collective of shops. The shop itself uses a wallet. So maybe you could be your own shop and you could buy and sell from your own shop. And so already with just the few pieces we built here, we've got pretty much infinite flexibility to maneuver these pieces without actually rewriting a lot of code. So there you go. That is my take on the interface segregation principle.